Okay, so we're going to go over some angles and their relationships today. The first thing we probably want to talk about is angles. So, an angle is formed when the intersection of two rays are formed. Okay, so here in this case is a ray, right? Notice this ray has an endpoint. Okay, and then we have another ray right here. Okay, where these two rays intersect, that's called the vertex, which is going to lead us to our next one. Now, usually, an angle looks something like this, where you have three letters. And the middle letter is called the vertex, which is exactly what we'll talk about. Okay, so the vertex is the middle letter. Okay, in this case, it would be B. Okay, so the interior of an angle is the part that's on the inside of the angle. So we have this angle right here. Anything that's in this piece right here is going to be the interior. So that is the inside of the angle. Okay. And then we want to talk about congruencies because sometimes we'll say that angles are congruent. When we say that they're congruent, we have this symbol. It kind of looks like an equal symbol, but with a little squiggly on top. That's the congruent symbol. In a way, it's the definition of equal. It's pretty much the exact same thing, um, and vice versa. So basically, it's saying having the same shape and size. Okay, and that was on her vocab a couple of days ago, shape and size. But in this case, we're dealing with angles, so that's what it means. And bisector is a key word. Okay, so when I bisect something, that means we cut it into two equal pieces. Cut into two equal pieces. This is super important. Um, because we can cut into two pieces. That doesn't necessarily mean that they're equal. And I showed an example the other day about pizza, but here I'll go ahead and do it again. Like if I have a pizza and I cut it into pieces, technically that right there is two pieces, but one's obviously a lot larger than the other. If I bisect the pizza, though, usually that cuts the pizza into two equal pieces. That's the difference between cutting into two and bisecting. Then we have this word adjacent. Adjacent in mathematics means next to. Okay. Mostly, when we say next to, when we're talking about angles, we're going to say that they share a common ray. They share a ray or a side, if you will, because the sides of an angle are rays. Okay. And then we have complementary. So this is the sum. And remember, sum means add. So sum of angles is equal to 90. And then you have supplementary, very similar. So complementary angles add up to 90. Supplementary angles, the sum of the angles is 180. And um, when we say supplementary equal to 180, kind of brings us into the next piece, which is a linear pair. Okay, linear pair is the combination of adjacent supplementary angles. So they're adjacent supplementary angles. That's the combination of what a linear pair is. So that means that they're next to each other and they add up to 180. So very similar. It looks something like this. So you can see our straight line, our straight angle, if you will. And then we have this angle right here where they show that they're supplementary. So these two angles will add up to 180. If we call this angle 1 and we call this angle 2, the measure of angle 1 plus the measure of angle 2 will equal 180. And they share that same ray right there in the middle. Okay, so that's pretty important. Now, the next thing we're going to talk about is vertical angles. And this is the one that really tricks a lot of people. Vertical angles are right across from each other, and they're very important because they're congruent. Okay, that's what's so important about that. That means they're equal to each other. Their measures are equal. right? So if I say I have two vertical angles and one's 90, then the other one must be also 90, okay, or 100 or 60, so forth and so on. Okay, so they're directly across from each other. So in this situation, if we're going to name a couple of pair of vertical angles, that would be like saying angle ABC, oops, ABC, and angle DBE. Those would be a pair of vertical angles. And let me highlight those angles real quick. So that's talking about ABC and angle DBE. Those two angles would be what we call vertical angles. Okay, and there's a whole bunch of them. There's technically four sets of vertical angles in here. Uh, but the next thing we're going to talk about is a pair of linear pairs. So remember, these are adjacent, so they should share a ray. Okay, so in this example, we could say angle EBD and angle, let's go with EBD, EBA. Those two angles are adjacent. So here's DEBD, we talked about, and angle EBA. Notice they share the same ray right there, and they form a line. They're supplementary. Okay, so that's why we call it a linear pair. Okay. So, what we want to do is we want to do a couple of practice pieces here. I'm going to go ahead and show this off. I'm going to erase this for now, and then we can come back to it. But it says here, if the measure, and that's what that means, should be the measure of angle ABE. That's talking about this angle right here is four. That's talking about this one right here. And the measure of angle EBD, which is this one right here, it's telling us these two expressions, 4x plus 5 and 6x plus 15. What are the measures of each angle? Well, first of all, what do I know about those two angles? So, real quick, angle ABE and angle EBD form a linear pair. And that's important because that means that they're adjacent, but they also are supplementary. Okay, so they're supplementary, they add up to 180. So we can make the equation, right? 4x plus 5 plus 6x plus 15 equals 180. That's what it means to be a linear pair because they're adjacent and they're supplementary. So you combine like terms, you're going to get 10x plus 20 equals 180. And then, of course, you do your two-step equations, and you should get x is equal to 16. Okay, and now that we know x is equal to 16, we can plug those in for each angle measure and solve. So that would give me ABE would equal, I believe it's 69 degrees, and angle EBD would equal 100 and I believe 11 degrees. Okay, check that, double check that, plug it back in just in case. Okay, so going on to the next one, I think we're still kind of using that same picture, if you will. This one says the measure of angle ABC. So we're talking about this angle right here, ABC, is 9x minus 16. And the measure of angle DBE is 4x plus 22. So what we're going to take here is when we find the measure of angle ABC, is that angle ABC and angle DBE are vertical angles. And that's important because that means that they're congruent. And we use this congruent symbol to mean congruent. That means they're equal. So we can set up the equation 9x minus 16 equals 4x plus 24. And then from there, we can go ahead and do some algebra, right? Get our x's on the one side, add 16. We get 5x is equal to 40. And then we solve x is equal to 8. Now, again, that's not our answer, but it's going to help us get to our answer. And we just have to plug that in for angle ABC. So ABC is 9x minus 16. So 9 times 8 minus 16. And that's how we get the measure of 56 degrees. So the measure angle ABC is equal to 56 degrees. Okay. All right. So, and then from above, it says, what is the measure of angle ABE? Well, that's um, ABE, right? So, if we're using this information here, we're going to say that they form a linear pair since we know, and we're using this previous problem that we're at right here, not the very beginning, but from above, what is the measure of angle ABE? Well, we found ABC right here. We found this one, which was 56 degrees, and it's saying the measure angle ABD, which is this angle right here. And we know those are a linear pair. So that means that they're supplementary. Okay. Linear pair means they're supplementary. So in other words, the measure of angle ABE plus 56 equals 180. That's what that situation is referring to. Subtract 56 from both sides, and the measure of angle ABE is equal to 124. Okay, even though it doesn't look like it, we're not really paying close attention to the drawing. It's just helping us figure out linear pairs and vertical angles. Okay, so last one. Okay, keyword here MS, right? MS bisects angle AMT. So keyword here is bisects. Okay, angle AMT. So that means that since that bisects, it's going to cut angle AMT into two equal angles. So that's important. We can use these little congruency marks. This angle, this means that this angle is congruent to this angle. Okay. If the measure, and I apologize again for all these typos, but if the measure of angle CMA, that's this angle right here, CMA, is 100 degrees, what are the measures of the other angles? So if that's 100 degrees, then you notice that angle CMA and angle AMT form a linear pair. That means they're supplementary. So that means that this whole entire angle here must be 80 degrees. Okay. Because 100 plus 80 is 180. Okay. And since it's 180 and that bisects the angle, right? That means that we just take 80, right? And we bisect it or divide it by 2 to get 40. And that gives us both angle measures of 40 degrees. And that's it. That's really how you would set it up. Or if you wanted to do the long way, 100 plus x equals 180. Same, you'll get the same answer. All right. Thank you very much.